Okay, shout out to Gigi and shout out to Will and who else? And Olivia. And that's it. Okay. We hope you guys have a great day. Anybody else we missed you. We hope to see you back soon. We pick up from where we were at yesterday. Yesterday, you found exact values of trigonometric functions at given points on the unit circle. So, if I am told that this is the terminal point, we'll see what you remember. Do you know the sine value given that terminal point? Why did I hear Rowan and Natalie say 12 over 13? So what would you say for this one? What would you say for this one? What if I told you were wrong? How would you feel? Okay. Well, you're wrong. So, all right. Here's what you need to realize. Sine is not simply just the y value. Sine is y divided by r, right? Now, if we're in the unit circle, what is r? 1. What if we're not in the unit circle? One of these coordinates is not in the unit circle. Which is it? Y is negative, or 3, -7, not in the unit circle. Yeah, just think about it, folks. If you have a unit circle like this, okay, and you plot the point 3, -7, that is so not in the unit circle, right? Okay, how would we verify that the other coordinates are in the unit circle? Unit circle, emphasis on unit. 1. What do you give you square 5, -5 over 13? Positive 25 over, what's 12 over 13 squared? Does that give you 1? Sure does. How about the next one, -2 over 3 squared? Does that give you 1? This does not give you 1, does it? We get 9 plus 49 is equal to 58, okay? So that's obviously not the unit circle. So what is the radius value there? We know that the radius for all these others is 1, but what is the radius for that one? No. X squared plus y squared is r squared. Square root of 58. R is square root of 58. Way to keep answering, Chris. So therefore, sine is -7 over the square root of 58. Can I leave it like that? No. So I get -7 roots of 58 over 58. See that? All right, let's go to cosine. What's cosine going to be for this one? How about for this one? Good, -2/3. How about for this one? Three over the root of 58. Can I leave it like that? 3 roots of 58 over 58. Do tangent. How do I do tangent? Y over x, so 12 thirteenths divided by -5 thirteenths. What do I do? Multiply by the reciprocal, and you get -12 fifths. Next one. What do we do? Negative root of 5 over 3 divided by -2/3. Negatives cancel. 3's cancel. Root of 5 over 2. How about the last one? How'd you do that so quickly? What? Y over x, tangent of t is equal to y, which is negative 7 divided by x, which is 3. Boom, done. We good? Did I make my point about the unit circle? Okay, that is not the type of problem that people don't do well on the test. That's just a review from yesterday. Are you ready for the good stuff? Flip your notes to the very back side. Ooh, make room. Or get a scratch sheet of paper. Yeah. It is time for us to learn some very important and fundamental identities, okay? All right. Now, Julissa's seen some of these before. Julissa and I had a nice experience with trigonometry, didn't we, Julissa? Julissa, how many fingers do you have on your right hand? Very good. Nice job. I'm going to ask you in class every once in a while, on a scale of 1 to 5, how important this is, okay? You'll have to hold up either 1 finger, 2 fingers, 3, 4, or 5. Now, if you decide to hold up 1 finger, you cannot just hold up your middle finger to me. That would be illegal. Because, Julissa, I know you, okay? All right? I'm not going to tolerate that type of behavior. Here we go. All trigonometry starts with Pythagorean theorem, which we have begun to understand is really the same as the equation for a circle, which is and we have chosen to do trigonometry while we're working in the unit circle because that is often easier. The unit circle would then be x squared plus x squared plus y squared is 1. Correct? Good. We all agree that I haven't made any of that up? Okay. So, yesterday you learned that x is the same as what trigonometric function? Cosine. So we can take that x and we can put a cosine in there. Cosine of theta squared. Plus, instead of y, sine of theta squared equals 1. Now, in trig, we get tired of writing the parentheses. So, we want to write it without the parentheses. So we write it like this. Sine squared of theta. Now, why don't we write it like this? Sine of theta and then squared like that. Why don't we do that? Because then it looks like the theta is being squared, right? So when you write sine squared of theta, it means this. Plus cosine squared of theta is equal to 1. This is fundamental trigonometric identity number 1. Julissa, scale 1 to 5. All right. YouTube, she said 5. Very proud. Tangent of theta is the same as y divided by x, correct? Oh, but we've learned that instead of y, what can you write? Sine of theta. Instead of x, you can write cosine of theta. Turns out tangent is sine divided by cosine. Important identity number 2. Jalissa, scale 1 to 5. How important is that one? Oh, all right. Jalissa has very strong feelings about these, if you can't tell. Okay? Very proud of her. Have I made any of this up yet? I'm not making any of it up. You should see exactly where it comes from. I'm going to give you another one. I'm going to start with sine squared of theta plus cosine squared of theta is equal to 1. This is where I start to lose people, but just try to hang on and don't get too lost, okay? Is everybody okay with that? I'm going to divide through by cosine squared. Is it okay to divide through by an expression? Is it okay to divide both sides of an equation? Yeah, right? We maintain balance. So what is sine squared divided by cosine squared, do you think? Tangent squared. What's cosine squared divided by cosine squared? What's the reciprocal of cosine? Somebody help me. Secant. This is important. Identity number 3. Julissa, scale 1 to 5. How important? Okay, all right. I probably would have put a 4. Thank you for 5. Very good. Math is more important to her than this. Yes. To come up with a new formula. Because that's useful. Oh, yeah. Come on up, Rowan. Come on up here. Yep, come on up here. Come on up, Rowan. What did you just say? Why didn't I?
Divide by sine squared.
Ask and you shall receive. All right, thank you. Go sit back down. Let's start with sine squared plus cosine squared equals 1. What do you want to divide through by? All right, we'll divide through by sine squared. Shoot, if only I knew what sine squared divided by sine squared was. Oh, it's 1. What's cosine squared divided by sine squared? Cotangent. What's the reciprocal of sine? Cosecant. That is important identity number 4. Julissa, on a scale of 1 to 5, how important? Okay, all right. I would have taken a 3, but all right. Okay, good. I like the way we're rolling here. Important thing to talk about before we start that big problem we need to work on today, okay? Are you hanging in there? All right, here we go. So we need to draw a coordinate plane, okay? So I'm going to draw a straight line. And I'm going to remind myself that sine of theta in the unit circle is y, cosine of theta in the unit circle is x, and tangent of theta in the unit circle is y divided by x. Wherever you want. This will be it. Everybody okay with what I wrote? Which quadrant is this one? This one? This one? 4 and 3, right? Now, here's what's interesting. Did you notice in your assignment yesterday, because I know that everybody did their assignment yesterday, because I told you how important the assignment was, so I know you would not leave this for like the weekend, okay? You would use that time while you were traveling to, I don't know, play hockey in Red Wing or wherever it was to do your assignment on the bus, right? Right? Yeah, exactly. And you notice that sometimes the sign value comes out to be positive, but other times it comes out to be negative. And sometimes cosine is positive, and sometimes it's negative. Sometimes tangent is positive, sometimes it's negative. Kind of be nice to know when that's going to happen, isn't it? Well, it all starts with this. We have x, y coordinates. In the first quadrant, the x value is positive, and the y value is positive. How about the second quadrant? So I got negative, positive, third quadrant, and fourth quadrant. Are we okay with that? Okay. So we have positive trig values. We have positive trig values, positive trig values, positive trig values. We have negative, 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 negative. What's negative in Spanish? Negativo. Positivo. Negativo, positivo, yes? All right. Is okay? And here we go. If sine is equal to y, then is sine positive or negative in the first quadrant? Is cosine positive or negative in the first quadrant? And tangent? True or false? If they are positive, then their reciprocals are positive as well. True, because reciprocal does not change the sign. It just simply flips them. Okay, second quadrant. What's positive? Sine's positive. Anything else? So cosine is negative and tangent is negative. Huh. Interesting. What about the third quadrant? Is there anything that's positive? Why? How can tangent be positive? You have negative and negative. Oh, but a negative divided by negative is a positive. Oh, you guys are smart. Okay, so tangent's positive, sine is negative, cosine's negative. How about the next quadrant? Cosine's positive. Why? Because the x is positive. So then sine and tangent are negative. Now, when I first learned about this, I learned, really sine is y. So sine's positive above the x-axis. Cosine is x. So cosine is positive to the right. See that? And tangent is y over x. So it's wherever they're the same signs. And that's how I learned it. I was helping my friend Lisa with trigonometry. The one who did SOHCAHTOA. I'm like, Soka what? SOHCAHTOA? Like, what language are you speaking? When we started with positive and negative quadrants, I started talking about x, y, and r. She's like, what are you talking about? I said, that's how you know where they're positive and negative. She's like, that's not what I learned. I said, what did you learn? She said this. She said, all students take calculus. I said, well, that's not true. It's like, well, that's what we say in trigonometry. I said, you're not even calculus. Why would you say all students take calculus? You are making no sense. SOHCAHTOA, Soka what? All students take calculus. I'm confused. She said, well, all of them are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. Now, you do whatever you want. I learned it without saying all students take calculus. I would say 2/3 of students probably think of all students take calculus when they do it. Okay? All right? Julissa, scale 1 to 5. How important is that? 5. Okay, so she didn't hesitate. She took 5. Okay, now Julissa, did you try to think of all students take calculus? You did. Okay. Does it make sense, though, that you can think of sine is positive above because it's y, cosine is positive to the right because it's x, and then tangent is same sign positive? Okay, So however you want to think of it is fine, but there we have it. You got it? Julissa, you were superb today. Let's give her a round of applause. Okay, that was a really good round of applause. Like, that wasn't even fake. I'm really proud of you. Okay, we get to problem number 1 on the test, and all of a sudden, I get a putz in class who does this. And you know what I do when you do that? I'm not kidding. I call home. And I do. I literally call home, and I say, I've only had to do it a couple times over the past few years, but I call home and I say, this is what your child did on the test. Like, well, they probably didn't know what was going on. That's why they wrote IDK. I said, unacceptable. And here's why. Watch. And you guys can tell me if I'm being too tough on you or not. Okay? It says, find the exact values of all 6 trig functions. It says sine of theta is 3/5 and theta is in quadrant 1. So instead of going IDK, what is one obvious thing that I could do? And yet I have people who don't write that. You don't do that, I call home. I'm not joking. And if you only do that, I still call home, because what else can I do? You don't do that, I call home. And I say they are not trying hard enough, and they should get out of this class, or they should get their butt in gear, 1 of the 2. Is that too harsh? I think that's reasonable. Okay. Negativo. All right. So now I got to figure out cosine. If only I had a formula that involved sine and cosine. Oh my gosh. I do. What is it? Yes. So here's what people do that you want to be careful of. They take the 3/5 and they put in for theta. They go sine squared of 3/5. No, It's you're squaring the entire value. It's 3/5 squared. Okay, 3/5 is taking the place of sine. Plus cosine squared of theta is equal to 1. What is 3/5 squared? 9/25 plus cosine squared is equal to, let's see, 1 is the same as 25/25, right? Now what? Subtract, and I get cosine squared is equal to 16/25. Oh, she's close. Plus or minus 4/5. Is it going to be positive 4/5 or negative 4/5? Why? All are positive in the first quadrant. You're so smart. Shoot. Now I got to figure out secant. So I'm going to have to use this one, right? 1 plus tangent squared of theta is equal to secant squared, right? Oh, I don't have to use that to figure out secant? What can I do? Let's take the reciprocal. Oh, sweet. So if I want to find tangent, then I have to use 1 plus tangent squared is equal to secant squared, right? No, I could just use tangent of theta is sine of theta over cosine of theta. So tangent of theta is what sine? 3/5 divided by, and I get 3/4. How about cotangent? 4/3. Yes! Not too bad, huh? That's the easiest problem I can come up with. I can't come up with one easier. You're not going to get one that easy on the test. Ready to step it up just a hair for the next 2. You got the premise down, the idea down? Okay. Ready for the big time? All right, let's go. You guys help me out. What am I doing? Okay. Okay. Do what? Okay, okay. Excellent. So Chris is thinking about the cosecant and tangent. Let's get to that later. First, let's try to come up with another value. Does sine squared plus cosine squared equal 1? Does that work right now? No, it doesn't. Because I don't have sine or cosine. I have a tangent. Yeah, 1 plus tangent squared is equal to secant squared. That's a nice one to use right there. So to answer Rowan's question from earlier, why do we generate some of these new formulas? Because in this situation, it's nice to have the tangent, isn't it? Yeah. Okay, so I've got that. So 1 plus, what do I get if I square the tangent value? 225 over 64 is equal to secant squared of theta. What to do now? Yeah, so I change 1 into 64 over 64. 64 plus 225. 289 over 64 is equal to secant squared of theta. Square root. 17 over 8 plus or minus is equal to secant of theta. Question is it positive or is it negative? This is where you need to lean in for the last kind of piece that people get confused about. Are you ready? Okay. I would say that I have people who get to the test, they'll get the test wrong, and they'll say, Mr. Gens, I actually never understood how to determine whether it was positive or negative. But I've never had a student in college trig or regular trig that I was not able to work with and help them figure it out. It's a matter of whether or not you ask the question. So here's what we have to be able to do. And if you don't get this, you won't get the problem right on the test. I'm going to figure out which quadrant I am working in. Is tangent positive or is it negative? Where is tangent positive? 1 and 3. So therefore, I'm working in either the first quadrant or the third quadrant. It's one of those two. Now I'm going to use my second bit of information. It says cosecant of theta is less than 0. What does it mean to be less than 0? Negative numbers are less than 0. So cosecant is negative, then sine is negative as well. Correct? Where is sine negative? Third and fourth. Cosecant's less than 0. Cosecant is the reciprocal of sine. So cosecant is the reciprocal of sine. If cosecant is negative, you agree that cosecant's negative, right? Then sine's negative as well. Okay? Where is sine negative? Sine's negative below the x-axis. So therefore, in quadrants 3 and 4. So which quadrant am I working in? Yeah, 3 is the overlap. That's where both of those things happen. So I'm in the third quadrant. Is sine positive or negative in the third quadrant? Negative. Negative. Cosine positive or negative? Negative. Negative. So is secant positive 17/8 or negative 17/8? Negative 17/8. If cosine, so let's suppose that cosine was negative 1/2. Then what would secant be? Negative 2 over 1. It doesn't change value when you take a reciprocal. I'm sorry, it doesn't change sign when you take the reciprocal. I'm in the third quadrant. Agreed? Quadrant number 3. Grace, you're right there. We just need to move 3 more inches, and you're going to get it. You agree we're in quadrant 3. In quadrant 3, okay, all students take calculus. Tangent's positive in that quadrant, but sine and cosine are negative. We're there. Got it. Okay, now what do I do? Oh no, if we only had some way to find out what sine was. Oh, we do? What is it, Jackson? Awesome. Sine squared plus cosine squared is equal to 1. So sine squared of theta plus, what do I get if I square cosine? equals 289 over 289. Now what? So I get sine squared is equal to 225 over 289 square root plus or minus 15 over 17. Is it positive or negative? Negative 15 over 17, so cosecant. Nice. You can, but people struggle because you're doing fractions then. Because you have a complex fraction. And when I've tried that in the past, I've had too many people say, now I'm confused. If you would like to investigate that, I'd be happy to sit down with you. But when I show the whole class, generally people get confused. Okay, last one. You guys are doing very well. You guys are guiding me through this one. I don't want to help you out hardly at all. What do I do? Good. Good. Sometimes when people square a negative, they come up with a negative. Every time you square something, you come up with a, unless you're squaring an imaginary number, and that will not come up in this situation, okay? I'm not squaring any imaginary numbers. 1/16 plus cosine squared. Good, 16 over 16. Okay. Okay. Mr. Dulitz is being very emphatic about including that plus or minus. Very good, makes me very happy. 4 in the denominator. I figure out whether it's plus or minus. Got a quadrant. Help me out. Very good. So I heard people talk about the tangent. Tangent is negative. Tangent is negative. I heard somebody say that if it's negative, it can't be in the first or third because that's where tangent is positive. So therefore, it's the second or fourth. That's what I know from this bit of information. Sine is negative in which quadrants? 3 and 4. Sine is negative below the x-axis because sine is the y value. Quadrant 4. So cosine is positive and secant is positive. Tangent and cotangent will be negative. You've done your determining work for the positive and negative signs. Very good. So I therefore have cosine is positive root of 15 over 4. How about secant? Miss Kruger is so proud of you guys that you can do that. Because it used to take you 3 minutes to do 4 over the root of 15 and convert it to that. And now you guys just fly through it. So when you guys see Miss Kruger, thank her for saying, thank you, Miss Kruger, for teaching me how to rationalize the denominator because I'm really good at it. So that's what it's called, you guys. You rationalize the denominator. It's okay. It shows the importance of visiting something and then revisiting it and revisiting and revisiting. Which, if I were to rewrite the mathematics curriculum K through 12, that's how I would rewrite it. Revisit, revisit, all the time. Okay. Last part. What do I do? So you said tangent is sine divided by cosine. sine is negative 1 over 4. We divide that by root of 15 over 4. So multiply by 4 over the root of 15. And we get negative 1 over the root of 15, right? Okay. Now, Natalie is doing an excellent job converting it, but I want you to pause for a second because I want to show you just a cute little trick you can do. Are you ready? Everybody agree that this is tangent? So cotangent would be the reciprocal, correct? What's the reciprocal? That's done. Now, Natalie told me that tangent, I would have to rationalize the denominator, correct? And I get negative root of 15 over 15. But my point is, find cotangent right away. Because otherwise, you would flip this, right? And you would get negative 15 over the root of 15. And that's where some of you guys start to get confused or make mistakes. So you're like, okay, well, times the root of 15 then over the root of 15. And I get negative, let's see, that's 15 roots of 15 over 15. And I think I could cancel those. Do I reduce that? No, I don't know. I think. Okay. It's just easier to flip it right there, isn't it? So kind of keep that in mind. So you did a really good job today. Today's assignment is extremely important. Unless your name is Cole Wenzel, who has a birthday tomorrow, all of you need to work on this assignment either today or tomorrow. And make sure that by Sunday night, you got a good grips on what you understand and don't understand. Okay? This is the hardest lesson for this unit. And on Monday, I'll teach you SOHCAHTOA, which makes Liz smile. Why? You like it. You know it. It's something that people love about trigonometry. And so we'll teach you SOHCAHTOA, and we'll do a little quiz, and all will be good. We good to go? Good job today, everybody. If you can't tell, I find trigonometry infinitely more exciting than algebra. I know, algebra is great until you get tired of it. So